Welcome to solverfy.
This is the answer to Chapter 20, problem number 3 from the Smith Organic Chemistry textbook. And in this problem, we're given 4 pairs of molecules, and we're asked which compound in each pair is more reactive towards nucleophilic attack. And so in order to answer this, we need to know that aldehydes are more reactive than ketones. And then when we're looking in carbonyl compounds with leaving groups, so amides, esters, the better the leaving group, the more reactive the carbonyl compound. So I guess it would be amides, esters, and acid chlorides. Okay, so then for A, we're comparing an aldehyde to a ketone. And so the aldehyde is going to be, significantly less hindered than the corresponding ketone. And so the aldehyde is going to be the more reactive carbonyl. Okay, so then in B, we are comparing two ketones that are pretty similar, but the first one is much less hindered than the second one. So the second one has an extra methyl group on an alpha carbon. So it has extra methyl groups on both alpha carbons. So it has an ethyl to the right as well. And so the first ketone here is going to be the more reactive one because it's less hindered. So then looking at C, we're comparing how good of leaving groups these two carbonyl compounds have. So we have an acid chloride where the leaving group is a chloride. And so that's a very good leaving group. And we're comparing that to a methyl ester. And so the methyl ester is a good leaving group, but the chloride is a much better leaving group. And so the acid chloride is going to be much more reactive than the methyl ester. Okay. And then lastly for D, we're comparing leaving groups again. So we're comparing a methyl ester to a methyl amide. And the ester is going to have the better leaving group. And so again, the one with the better leaving group will be the more reactive of the pair. Okay, and so that's the answer to this problem. And in order to get there, we just need to remember those rules for determining reactivity in carbonyl compounds. And that's the answer to Chapter 20, problem number 3.